Today we're going to begin our discussion of Unit 6-1, Exploring Accumulation of Change. So let's say we have a car going down the road at a constant speed of 25 miles per hour. And he continues at this constant speed until 3 o'clock. Then at 3 o'clock, he instantaneously increases his speed to 50 miles per hour and continues going at a constant speed of 50 miles per hour until 5 o'clock. So we would like to know what distance is traveled between 2 o'clock and 5 o'clock. So let's say technically he starts off at 1 o'clock, okay? So therefore, that's his starting point. He hasn't traveled any distance, but immediately he increases his speed to 25 miles an hour and drives down the road until he gets to 3 o'clock. So if he started at 1 o'clock and he was 0 miles at that point and traveled for 1 hour at 25 miles per hour, at 2 o'clock he would have traveled 25 miles. And then if he continued on until 3 o'clock, that's another hour at 25 miles per hour. So at 3 o'clock, he would have traveled 50 miles since his start at 1 o'clock. So at 1 o'clock, he was 0. At 2 o'clock, he had traveled 25 miles. And at 3 o'clock, he had traveled 50 miles because he was going at a constant speed of 25 miles per hour. All right, so at 3 o'clock, he's traveled 50 miles. But at 3 o'clock, he instantaneously changes his speed to a constant 50 miles per hour, which he continues on until 5 o'clock. Well, if he's traveled 50 miles at 3 o'clock, in the next hour, he's going to travel another 50 miles since he's going 50 miles per hour. So at 4 o'clock, he would have traveled 100 miles. And again, if he continues on for another hour at a constant speed of 50 miles per hour, by 5 o'clock, he would have traveled a total distance of 150 miles from his start at 1 o'clock. So let's look at our picture here to see how far he would have traveled between 2 and 5. Well, let's say the starting time is at 2 o'clock, all right? He's going 25 miles an hour, so at 3 o'clock, he would have traveled 25 miles from 2 to 3. But at 3, he increases his speed to 50 miles per hour, so until 4 o'clock, he would have traveled an additional 50 miles, or now 75 miles from 2 o'clock. And then from 4 to 5, he would travel another 50 miles, so that his total distance in going from 2 o'clock to 5 o'clock would be 125 miles. So this is just using a little chart mechanism here to take and figure out how far he would travel between 2 o'clock and 5 o'clock. But let's say we want to graph this and wanted to look at it from a graphing perspective. So let's graph where the vertical axis is going to simply be velocity, all right? So this is going to be his speed in miles per hour. And the horizontal graph is going to be time in hours, all right? So if you look at it from the previous slides, at 1 o'clock, he's going 25 miles an hour, and he goes at a constant speed of 25 miles an hour from 1 o'clock to 3 o'clock. Then at 3 o'clock, he instantaneously increases his speed up to 50 miles per hour, and he stays at a constant speed of 50 miles per hour until 5 o'clock, all right? So this is what it would look like on a graph. So now let's say we want to use the graph to calculate how far he would travel between 2 o'clock and 5 o'clock. So if I look at my graph, from 2 to 3, he's going at a speed of 25 miles per hour. And from 2 to 3 is 1 hour. So 25 times 1, or the area under this portion of the curve right here, is going to equal 25 miles. Now from 3 to 5, he travels at a constant speed of 50 miles per hour. But from 3 to 5 is 2 hours. So 50 miles per hour times 2 hours, or in this case, from 3 to 5, he travels 100 miles, okay? So the area under these two curves we can use to determine what the total distance he traveled from 2 to 5 o'clock. So if I simply add up these two numbers, 100 and 25, I get the total distance that he's traveled between 2 o'clock and 5 o'clock is 125 miles. Okay? And we got that by using the graph and determining the area under the graph between these two times of 2 o'clock and 5 o'clock. Well, that graph was somewhat simplistic in that we were going at a constant speed of 25 miles an hour and 50 miles per hour. But that doesn't really represent true life. In reality, your speed is going to vary. In fact, let's say this is our velocity curve, where again, the vertical axis is velocity and the horizontal axis is time. But notice the velocity with time is changing. Well, if we wanted to determine how far this person travels between 2 o'clock and 5 o'clock, we would basically have to take and figure out what the area is under this curve in this region. But how are we ever going to do that? This isn't a straight line, so we can't divide it up into rectangles and figure out the area that way. But how would we go about doing that? Well, that is going to be a subject for a later lesson, and we will learn in a later lesson how we actually do determine the area under a curve where it is not a straight line that you can divide up into rectangles. So that's to be continued in our next lesson.